So if you put input of 4, then the output is 0. So now let's test out a number next to 4. Do you want to do 3 or do you want to do 5?
5.
5. Okay. So input of 5 for x, and then you're going to have 2 times 1, which is 2. So that is going to be our next coordinate, 5 comma 2. Hey, do you see how far it went up? How far did it go up?
2.
2. So that's going to be our new stairs. Our new stairs aren't going to go up by 1. They're going to go up by 2. Okay? And we could prove it. Let's do 6. All right, so plug in 6 for x. All right, so we have here 2 times 2, and this equals 4. So how far did the new step also go? Plus 2, plus 2.
2.
There we go. So now we can graph this thing without having to do so much work. And let me just kind of slide this over here. Recall that I want to start at the vertex because that's the bottom of my stairs. At the very, very bottom of my stairs, right? Does that make sense? And you can call this, it's the vertex, of course. And I like to do analogies, so I call it the bottom of steps. Now the new one, we're going to go up to, and each step, by the way, is always 1. And does anybody know why it's always 1? Anybody have any ideas? And by the way, your stairs, you kind of don't really want to make them too thick, right? Just kind of lightly, okay? Anybody have any idea why the step is always 1?
Because if it's more than 1, then it probably won't be a straight line.
Let's see. Let's find out, okay? By the way, check this out. If you went side to side, this is the change of the x, right? It used to be 4, now it's 5. What did we change over here on the x's? How far did it go?
1.
1. This is the width. This is the width of steps. We only went up by 1, and this will be your height of steps, right? Does that make sense? So we went up by 1 on the width, but the height went up by 2. All right, so now we go to here, and I could do the same thing over here on the left side, right? I'm going to go up 2 over 1, up 2 over 1. I'm going to do it lightly because eventually you kind of want to erase this, right? Just like you would do when you would when you would build a building. I don't know if that's the right term. You use a scaffolding, right? Well, you guys finish that off. I'm going to use my analogy to show you what scaffolding. So this is scaffolding right here. So the scaffolding is used to create your building, right? This is all scaffolding. But when you're done with your building, you definitely want to take your scaffolding, okay? So think of the steps as scaffolding. They're not really part of the building, but they're helping you create your building. All right. So let's review. So first step is steps. Find vertex, all right? Find vertex. And how do you find the vertex, by the way? How do you find the x value of the vertex? Anybody have an idea? We did it here a couple times, by the way. And I'm gonna highlight it, but I'll wait for you to kind of save that. How do you find the x value of the vertex?
The number that makes what makes the number inside 0.
Exactly, because that's going to give you the lowest number. That's going to give you a 0 as an answer, right? Look at this. It's going to give you, what is this? That's the lowest number, okay? So that's the number is going to give you the lowest 0. So I'm going to write the number, the x, well, let's put a number. The number that will make the inside 0, right? 0. And inside, I mean inside of the absolute value, okay? All right, let's do a quadratic, okay? And is it okay if I just kind of slide? And let me just slide. I wonder how big this page is. All right, I'm gonna use a different color for the quadratic. All right, so here's a quadratic. I'm gonna call it r of x equals x plus 4 squared. All right, what was step 1?
To make the number inside a 0, so
Yep.
it'd be -4.
Exactly. So we're going to find the vertex, and that number is going to be -4. So that's going to be -4 plus 4 squared. And what is -4 plus 4 squared? That's going to equal 0 squared, and that's going to equal 0. So that's our table, right? -4 gives you 0. This is the lowest. This is the bottom of steps, right? Bottom.
I have a question.
Yeah, go for it.
So if it's 4 squared, so wouldn't it be like -4 plus 16?
Oh, so good job. So if you plug in -4 here, you actually want to take care of the adding first, and then squaring that. Does that make sense, Armand?
Yeah.
So yeah, it's not this, right?
It does.
Does that make sense? So it's not that. It's actually inside first. PEMDAS, right, says do the parentheses first, right? Okay, good job. So this is the bottom of our steps. So let's go ahead and create a table, a graph. And let's see about the steps on a quadratic. Do you think the steps on a quadratic are going to be the same height, every single one, or are they going to be different?
Can you move it up? I can't see the graph.
Yes.
The table graph.
I got you right there.
Thank you.
You're welcome. Okay, so here's, whoa, I was going, all right. So, do you think the steps of this one are going to be the same, or are they going to be different, or you're not sure yet?
I think they're going to be the same.
All right, let's find out. Vertex. All right. So what number is next to -4? You want to do -3 or you want to do -5? Which one you want to do? Do you want to do this one or this one?
-5.
All right, let's do -5, okay? All right, so we're going to plug in. I'm going to use red for my, we're going to plug in -5 plus 4. All right, so what is -5 plus 4? Okay.
-1.
-1. And what is -1 times -1? That's positive what? Positive 1. So now we have our y value, right? I'm going to put it in green. So that's going to be, what are we plugging in 1? Okay, so we know our first step is up 1 over 1. That's our first step. Up 1 over 1. That's cool. All right, let's find out our next step. All right, so we should do -6, correct?
Yes.
All right, let's plug that in. So we'd plug in -6 right here. All right, so what's -6 plus 4? I think about it as 6 minus 4, but it's negative because there's more negatives. And what's -2 times -2?
+4.
+4. So now we know the next one. Hey, by the way, how much bigger did the next step become?
By 3.
It went up
+3.
+3. It actually, the step got bigger. So the steps didn't stay the same size. This step got bigger. It went up 1, 2, 3, and over what? 1. So it's +1, +3. And what would you guess the next one would be?
Up 5.
Up 5. 1, 2, 3, 4, 5, and over 1. Do you see how I'm doing less math now? Am I doing less math, or am I using maths patterns too? And what do you think the next one's going to be? How far am I going to go? 7. 1, 2, 3, 4, 5, 6, 7. And oh, look, I got my y-intercept. Okay. All right. So now I can connect this smoothly. Now this is smooth curve, and there's a reason for that. Like the absolute value is just a sharp 2 lines, right? Just like 2 lines bent at the at, what do you call it? The vertex. All right, so we have the right side of the function done. Do you think the left side is going to be identical? Absolutely. Okay. So
yeah, I think so.
Yep, it will be. That's how quadratics work. They are symmetrical. Do you notice how I stopped doing algebra? I stopped doing math. Now I'm just kind of drawing. Now you don't have to. You can actually plug in any number you want and do a lot of math, or you can understand how it works and then use that. Okay. Now I have to kind of sketch it like this because I want it to make it smooth, and I know it's harder for you to do it on, right? And make it smooth at the bottom. Okay. And don't forget to put arrows. The arrows mean it goes on forever. Okay. All right. So now let's compare our steps. Okay. So our steps for quadratics, right? For x squared. So I'm going to use green. So it goes up 1 over 1. I'm just doing it like a little reminder, right? Then up what? 3. Then up 1, 2, 3, 4, 5. And then up 7. And then forever. Do you guys agree? It just keeps going on and on and on. Okay. Steps get larger. And what were the steps for an absolute value? Did they get larger or did they stay the same? What do you guys think? I think we did that. All right. So, and this is, by the way, this is why I was doing this earlier, right here. Okay. I was trying to do this. This is what I was trying to copy this. There's probably not a Google image of this, or maybe there is. There's everything in Google. Okay. All right. So let's look at one more, and then I'm going to do some Khan Academy with you guys. Okay. We'll do it together. All right. Can somebody come up with any function that you'd like to try that's either a quadratic or an absolute value? We're going to graph it really quick. So can somebody come up with one? And you can actually add something to the end. Okay. Well, what would you like to name? What would you like to name your quadratic or absolute value? Which one would you? Anybody with me?
T.
T. Okay. T of x. And what would you like to do to that t? Would you like to double the steps, triple the steps? What would you like?
Double.
Double. We're going to double the steps. Do you want it to be a quadratic or do you want it to be an absolute value?
Quadratic.
Quadratic. Look at this. This is your doubling. Double what? All right. And what would you like to do to the inputs? Would you like to add 3 or subtract 3?
Subtract 3.
Subtract 3. All right. And at the very end, would you like to add 4 or subtract 4?
Add 4.
Add 4. There we go. Cool. We got 2, 3, 4. Perfect. All right. What was the first step of my how to graph easily Quinones style? What was the first step?
To take the number that's in there and make it 0?
Yes. Find vertex. Well, we're going to find the x of the x, right, of vertex. All right. And what number will go in here that'll make this become 0?
3.
3. So that's going to give us 3 as a vertex. Vertex 3. All right. Now let's do some math. All right. So we're going to replace x with the number 3, and we're doing that on purpose, right? Because this is going to become 2 times 0 squared plus 4. This is, what's 0 squared? 0. What's 2 times 0?
I have a question.
Yeah.
So for every time we're trying to find the vertex, like the 0 on the inside, would it just be the same number but like opposite?
Yes,
like,
exactly. Because the opposite of another number will make a 0. Right? Now, there is one case which I would try to do a sneak attack on you, like this. What number can you put in here that you're gonna double it and it's gonna get rid of 4? Is negative 4 gonna work at this time?
No.
No. This has to become negative 4, right? This has.
So would it be 2?
Yes. Or 2 would become 4. What kind of 2?
Negative 2.
A negative 2, exactly. Yeah. So when you have an extra number out here, you need to consider that. So the number you would have put negative 4, right? Originally. Well, you're gonna have to half it, right? Because we're gonna double it.
Can you move the graph up again?
Yeah, definitely.
Yeah.
Let me. You know what it is? It's all in my little screens that are hiding here. All right. I don't know what's going on here. Okay. Cancel that. Cancel that. All right. So.
Actually, how do you share what's going on your computer screen? Like in addition to like being able to show your.
Oh, so I do. On you also can share your screen too when it says present. So if you ever have a question like on Khan Academy, if you click present, you'll show everybody your question, then you can unpresent. All right. And
I could also like present what's going on like on my phone screen, like.
Probably, yeah.
Present YouTube.
Yeah.
For example,
probably.
Yep.
All right. So where is the bottom of our steps?
I try it out.
Yeah. That's right. We'll try it out in a minute. Okay. So it's going to be 3, 4. That's going to be the lowest part of our graph. 3, 4. All right. Okay. Okay, 3, 4 is going to be right there. And our normal steps for a quadratic are 1, 3, 5, 7, right? A little bit taller. What's this number going to do? Remember the first 2 you guys wrote in there? So let's pretend that we don't know, right? So what number would you like to input? Would you like to do 2, or would you like to do 4? Which one's easier?
2.
2. I agree with that. All right, so let's put 2 in our quadratic for x. I'm going to put 2 here. So here we go. 2 minus 3 is -1 squared. -1 times -1 is +1. And then it becomes 2 plus 4, it's 6. So this is going to be 6 right here. And this is also going to be what? So how far did the steps, what was the size of the first step? The height?
1. Oh, wait.
Yeah,
Plus 2.
Yeah, the width was 1, right? But what was the height? Plus 2. All right. What do you think the next height will be?
4.
Let's see. Remember the first. Look at the. Yeah. Look at
It'll
the.
be 8.
Look at the steps over here. 1 became 2. It got taller. The first step was 2. It used to be 1, but now it's 2. So let's do the next step. Let's pretend we don't know. It could be 4. It could be 6. Let's find out. Let's plug in. What would you like to plug in? Would you like to plug in 1, or would you like to plug in 5? Which one would you like to plug in?
5.
All right, let's do 5. All right. 5 minus 3 squared plus 4. 2 times, this becomes 2 squared. What's 2 times 2? This part right here. 4. 8. This is 12. So this is 12. So how much did it go up by? Whoops, hold up. Whoops. Press the undo. How much did it go up? How much do you go up from 6 to 12?
6.
6. And what did it originally go up by on the second step?
2.
Now look at the stairs over here on the right side.
3.
3. But now it's 6. So how do you become 6 if you used to be 3? By adding or multiplying by
Times 2.
times 2. So this is really 3 times 2. And the original one is actually 2 times 1. What's the next one going to be? 5 times what?
24.
What 5 times 2? What is 5 times 2?
10.
10. So the next one's going to go up by 10. So our steps aren't 1, 3, 5, 7. They're double. What are they? Double. Double means they're really tall stairs. Okay. So the next one, we're going to do a plus 6. All right. And if you plugged in a 0, we're going to add 10 to that. And what's 12 plus 10? 22. All right. Excuse my mess here. All right. And all right, let's graph this. And quadratics, you can't really do a lot of points because they go up really fast, right? Especially these stairs. Look how big the stairs get. All right, so the first one was 3, 4. The next number was 2, 6, 3, 4. Hold up. 2, 6 right here. And the next one was 1, 12. And then right there. And on this graph, I can't really plot the rest of the points. They're too high, right? All right. So the review of this little lesson here is find vertex, right? And I'll write it down in here. And then do the stairs. Okay. And that's going to be today. Right? Let's do one last one, and then we'll call it a day. Okay. There we go. All right. Let's do another function named t. Well, I think we already used t. Let's do a for Armand. Okay. Here, let's stick with hold on. Let's stick with like whole numbers for now. There we go. All right, step 1, find vertex. All right, go ahead and find the vertex by yourself, and don't shout it out. Go ahead and type it in the chat once you have it. So remember, you're trying to make the inside of the parentheses equal 0. And let's see if I can figure this out, how to find the chat. All right, what is that vertex? Or you can at least tell me what number will make the inside become 0.
-4.
-4. All right, and go ahead and plug in -4 and then do the math. And then Nathan already got that. All right, Nathan. And also, what I'm going to ask, and you can also answer this too, how big are the stairs going to be? What's the size of the first stair? And what's the size of the second step? And what's the size of the third step? So I want the first step, the height, the second step height, and the third step height. All right, Van says -4, 5. Okay. All right. Anybody else? Oh, sorry, Amar.
Don't listen to Van.
All right.
What's he talking about?
Oh, I keep calling Amar Armand. I don't know why. I'm so sorry. You could call me Manuel. Some people that don't know me, they call me Manuel instead of Miguel, because like my name is Miguel, not Manuel.
I just prefer to ask Keenan as.
Thank you. Okay. All right. So if you plug in a -4 here, you got to do the math. And after a while, you'll stop doing math. But for now, you're going to see that this is going to become 0. And 3 times 0 is going to be 0. And what's still not affected? So which number survives when you plug in a -4? All right. So Van, so the vertex is actually, the vertex is going to be -4. Whoops. How did that happen? -4, -5. So this number survives when you plug in a -4. All right. So -4, -5. So -4, -5 down here. All right. So class, what's the size of my first step? My first step used to be 1, and then the next one's 3, and then the next one, I'm just going to write this on the side, right? 5, and the next one's 7. But what is this 3 going to do to those size of steps? What is this 3 going to do to those stairs? Can you guys think about that and let me know? What do you think is going to happen to these these numbers 1, 3, 5, 7?
They'll double.
They'll double. Well, but look, it's actually there's a 3 there. What's the word triple? They will
Oh my god.
yeah, they will triple, right? So what is triple of 1? 3. What's triple of 3? 9. What's triple of 5? And what's triple of 7? So these are going to be my sizes of my steps. So what's my very first step? My very first step, what's the size of it? 1, 2, 3. Remember, each step is always over 1, right? All right, what's my next step, class? What size is my next step? What size is the next step? And I have the answers over here. And I'm literally pointing an arrow to it. 2 arrows. I'm circling the answer.
9.
Thank you, Amar. All right. So up 9. Change colors. 1, 2, 3. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you don't have graph paper, just put a number. Make it really tall though, right? Make it tall. Make it look like it's not the same as the 3. All right. Now I don't think I'm going to be able to draw my next step, but what would be my size, the height of my next step? Somebody else? What would be the height of my next step?
15.
15. Now, I'm going to go off the graph, right? I'm just going to write 15. So this is, if this was, what do you call it? Real steps, I wouldn't be able to reach them anymore, right? I'm sure I can go up a 3-foot step. A 9-foot step, I don't know if I even could do a 9-foot step. But for sure, I wouldn't be able to do a 15-foot step. Okay. All right. Anyway.
Bungee jump?
Yeah.
Maybe you can.
Maybe you could. Yeah. Maybe if I was going down, right? I guess if I was going down, I could probably do it with a rope. Now, what about the other side? Same what? Same thing. Do you notice how I didn't really do any more math? I just how much math did I do? Look at this. How much math did I do? Only where? Only right there. Now,
not a lot.
Not a lot, right? I just found that vertex, and that's it. Now, that's why my teacher used to hate that I didn't show any work. Because with time, you're gonna do this with your brain. You won't even have to do it. You'll know that this is the size of, you're gonna triple all your steps, and your vertex, you're gonna be able to see, right, Amar? You're gonna be able to see, hey, you're gonna just do the opposite of this number, and this one survives, right? That makes sense? And then your steps, it's always 1, 3, 5, 7 times whatever number's out here. Okay. And so when I would graph this, I would actually just have the graph. I wouldn't have any work, and I would get like in trouble, right? I'd get points taken off on a test. But that's okay. I don't want you to think that you can't do that. As long as you understand, that's what matters. Okay. All right. And then we're going to stop with this one. And then that's going to be it today. We're not even going to do Khan Academy today. Okay. So the last one we're going to do the same thing, except it's not going to be a quadratic. It's going to be an absolute value, the same numbers.
Khan Academy today?
Nah, we'll be done. My goal is that you don't have extra work once we're done with the class. Okay.
Okay.
So what about the 3 Khan Academies in the?
We'll do them tomorrow together. Okay. Yeah, you can look at them and play and try to do a few if you'd like, right? but tomorrow we'll just do them together, okay? All right. So here's the last one we have for today. Okay. And this is not the last one. This is the real last one. Okay. So we're going to do, let's see who's online here. Van. We're going to put v of x equals 3 times absolute value x plus 4 absolute value minus 5. All right. So let's graph this really fast. All right. What is the vertex, everybody?
-4.
Negative. Yeah, that's the x of vertex, right? Remember, the vertex has two parts, the x and the y. So what's the
-4, 0.
-4, 0? You're right. If you put -4 here, this is going to be 3 times 0. But what about who survives?
The 5.
The -5. Yeah, exactly. So this, now, okay, I'm going to make a joke. It's not a good joke, but you get the idea. Think of the x of the vertex as the number who's going to blow this up. Okay? This is going to blow this up, right? It's going to blow it up and is all going to become what number? 0. But which number doesn't get blown up?
-5.
The -5. Yeah, the -5 survive. That's why I use the word survives, because I used to use that. But then I thought, oh, we don't want to be blowing things up, and so. But get the idea that -4 will blow this up, but -5 doesn't get affected. They're like still alive. All right. So it's going to be -4, -5, the same as the previous one, right? So vertex -4, -5. All right. Now this is not a quadratic. So what is our step sizes? Are they going to stay the same, or are they going to change? And you can look at your notes from previous. With absolute value, do the steps, do they stay the same, or do they increase? So is it this one, or is it this one? Is it the same size steps, or are they the quadratics that get bigger and bigger? Anybody? Well, let's find out, okay? Let's find out. So if we plugged in -4, we need to plug in a number right next to -4. So would you like to plug in -3 or -5? This is the vertex, right? This is the bottom, right?
-3.
-3. Yeah, you could do either one, right? Either one's going to give you the same answer, because that's the bottom of the steps. So we're going to plug in -3. So 3. Oh, I almost made that in parentheses. It should be absolute value. All right. So we got 3 times this. This is going to become a 1, right? So what's 3 times 1? 3. And then 3 minus 5 is negative. Wait, hold on a second. Yes, 3 is -2. So that's going to be our answer. So how far did it go up? -2. How far was the step, the first step? I'm going to use brown for my zoom.
It went up 3.
It went up 3. So once you know your first step, do you need to do the second? Do you need to do the math for the second step? This was also nope. Absolute value. They're boring steps. They're the same way. Same size every single time. So if you know this, then it becomes easier. If you don't know it, well, then you can just plug in numbers until you get bored of typing in numbers. Make sense? All right. So write yourself a note. Absolute value, the steps are the same size. Now, what size are they? Well, it depends on the number out here. If there is no number out there, then that's 1. 1, 1, 1, 1, 1. Quadratics, they're always 1, 3, 5, 7 times that number outside. Okay? So, what I want you to do, and I'm going to give you extra points if you do this, okay? This, I'm going to give you extra credit points, but I'm not going to write that down. You're going to write it down, and if you write it down, I'll know that you were listening to me. And if you don't write this down, I know that you weren't listening to me. So inside this little bubble thing, you're going to write down absolute value, the steps are the same size. Quadratic are always 1, 3, 5, 7. So they get bigger and bigger. So if you do that little piece, I'm curious to know which students are just copying down my notes and which students are listening. Okay.
Can you repeat it one more time?
Yes. So inside of this little bubble,
Maybe write it down.
well, if I write it down, people are going to know, right? So I'll be real slow. Absolute value functions, the steps are the same size. Each step is the same size. So absolute value, the steps are the same height. The same height, right? Same height. Same height. Quadratics, the steps get bigger and bigger. So this is the absolute value, and this is quadratics. This is x absolute value, and this is quadratics. Make sense? All right, how many points do you want me to give you? Double points or just 5? So if you write, yeah, I'll do double.
And how does the point system actually still work in this?
So what I do is, if students take down the notes, I give you 10 points. But if I obviously tell that you didn't really do all of the notes, I'll give you a chance to redo it. But I'll give them like a 5 or a 3. But I always give students a chance to like do it again. Some students would they'll do like some really they'll literally just give me a picture of like the very beginning, maybe this right here, right? And I know for sure we took a lot more notes than that, right? Look at this. How many pages
Actually,
do you guys have so far?
Actually, how does point system towards potlucks still work?
Oh yeah, well we're just pretending. Yeah, one day we should just have a virtual potluck. All right, so for this one, I'm going to give you 20 points on this assignment. Okay. Now, some people have like 115% in the class, and that's really good because I'm not going to give out any like real test. You know, everything's going to be on what you do. Okay. So you can walk out of this class with an A+. Okay. So remember, double points if you fill in this right here. And that's actually today's lesson was that was like the big deal, that the steps are the same size for absolute value, and quadratics, they're taller and taller and taller. All right, cool. Any I think that's all for now. Let's cut it short, and everybody have a great day. Okay, go ahead and post a picture of this. In a few minutes I'll make the assignment. Okay.
So how do I show?
Oh,
so how do I show?
Yeah. So click on present.
Present. All right,
Let's see.
Bye, Mr. Quinones.
Bye. Bye, Claudia. Let's see. Let me see if I can help you with that.
Thank you, Mr. Quinones.
Thank
Bye.
you. Bye. Thank you, Olivia. Bye.